sorry, you can hear my beeping because that's how I prepare to get started. All right. So this is one question, type of question you're going to see on, can you see my screen? Okay. All right. And I honestly, I see only 4 people on my screen now. And one is with the camera off. So like I said, I just hope you are watching. Okay, because it's really hard when I can't see all of you and I don't know. Oh, now I see more of you. All right, I do see lots of eyes on the screen. Hopefully you are listening. So there's a question like this that they were going to ask you. You notice that all of them have this number in it. Okay, so the question is about scaling. That means you don't need to multiply to solve to figure out your answer. Okay, so the question is going to be for you to select which one will give you a product. And if you don't remember, product is the answer to a multiplication question. Okay, product is an answer to a multiplication question. So the answer to these questions, some of them are going to be less, some of them are going to be equal, and some of them are going to be greater. So I'm looking for one that is greater or more. I mean, more than one, I don't know. Product that is greater than 1 5/8. So that's the number I'm comparing to. We are looking for numbers that for expressions that when if solved, we are not solving, we don't have to. If solved, would give me an answer that is actually greater than this. Okay, so my first question to you is, well, I'll do this one here. What do we know about any number multiplied by 1? What do I get when I multiply any number by 1? Alice, you get the number you started with. Let me move. See, when I do this so I can see who raises their hand, I miss the hands going up and then I miss, so here, 1 5/8 times 1. The answer is going to be 1 5/8. It's the same thing. Now, be careful. This one, sometimes they're going to trick you. They may write this as not 1, but they may write it as 8/8, or they may write it as 6/6, or 5/5, or 4/4. As long as you know that these are the same thing as 1, your answer is going to be the same as it was before. Okay, so if there is a 1, it's the same answer. If they have this 1 5/8 times 8/8, or times 4/4, or times 6/6, well, that's still a 1. The answer is still the same. Yes, Falaki? Okay. All right. So we know this gives me the same product. I mean, the product is the same as this number, and we are looking for greater. Well, based on that, now we want greater than 1 5/8. Based on this, knowing this, who can tell me one that the answer is going to be greater than this? Remember, anything you multiply now by anything that is greater than 1, your answer is going to be greater than what you started with. If you multiply by 1, you get the same. If you multiply by something greater than 1, you're going to get something greater than you started with. So look at these 3. Here I multiplied by 3/4. Here I multiplied by 2 1/4. Here I multiplied by 1.5. Who can tell me one that when I multiply this by is going to give me an answer that is actually greater than this? Who can tell me? You can raise your hand. I can see it now because I pushed the screen. Nobody? Jimmy. Greater than that, when you multiply, you're going to get an answer greater than the 1 5. Very good. This is one of them. This is one of them. Why? Because this, I don't even need to worry about the fraction. This number is a 2. Obviously, I would have to multiply everything here, but if I were to multiply only the 1 times 2, it's already 2. So it's already over this, right? And I still would have to multiply the 5/8. So here is greater than 1. So your answer is going to be greater than that. Now, who can tell me what you know about 3/4? Is 3/4 the same thing as 1 whole? Is it less than a whole? Or is it greater than a whole? Who can tell? Denzel, less than a whole. That means you're multiplying this by something less than 1. So your answer is going to be less than this. I already know. So that is actually a strategy to help you uh, the help you with process of elimination. If you're multiplying something by a fraction that is less than 1, your answer has to be less than this. If it is the same or greater, you did something wrong with your multiplication. Okay, as we do the word problems, we will look into this to just see if it can, help more. Now, how about 1.5? So here is the same. Here is the same or means equal to this, right? Here is going to be less than this. Here is going to be greater than this because it's greater. How about 1.5? What do you think? Is 1.5 this equal to 1? Is 1.5 greater than 1? Or is 1.5 less than 1? Alice. It is, oh, there you go. It's a mixed number, right? And also here is the number 1. If I had only the number 1, it would be the same. But I have an extra half there. If you have a number line, you have the number 1. 1.5 is past it. So it's greater than 1, right? So the answer would also be greater than 1 5/8. Okay, so the answers, the choices would be this and this because these are greater than 1. This is less, it would be less. This is 1, it would be the same. Okay, so as we do word problems, I will talk about it with you. Okay, we will ask those questions once we pick the numbers and the operation. This one I'm going to just quickly review because we just finished that topic, but you will have questions about volume, and you have those videos there. The only thing I want to talk to you is that the formula for volume is length times width times height. So you need to look at the front, which is my length. That's how I like to sit. The side, which is the width, and the height, which is the going up, how tall it is. Sometimes, remember, they may not give you a number for a side. You have to look at the opposite side because, in a rectangle, opposite sides are the same measurement. So you have to hunt for that number. So here, in this case, if you have to solve the volume, which is how much space that box takes up or how many things I can fill, or if I were to put cubes inside the box, that's going to tell me how many cubes I can put in that box, okay? You have the length, you have the width, and you have the height. But be careful. If a problem gives you the area of the base, what it means, they gave you the length and the width multiplied already for you. So that means you don't have to do this part. It's done for you here. This area of base, this is it here. So what you're going to do, you still have to multiply this by the height, Usually when you have that problem with area, they give you area and they give you height. And they will say area. So in the problem, they would give you area and they would give you height. Multiply area times height. There you go. Or if they give you length, width, and height, multiply those three because these two here represent the area. Okay? All right, so I'm moving on with this because my goal was not much with volume. There are videos there for you to review. So here we have a problem. I'm going to read and you're going to decide with me whether we are adding, multiplying, subtracting, or dividing. Okay, I'm going to read and I'm going to circle some words to help you. This one I will actually do with you. Okay? Here, 3/8 of a gallon of milk. Julie had 3/8 of a gallon of milk. This is what she has to make pancakes. She used or needed, I don't know why, 1/5 of that amount of milk. How much milk did she use? Well, I'm going to talk to you about what I boxed here, because this is something that it can, am I subtracting or am I doing something else? Okay. When you read she used, guess what? Many of you thought about, oh, subtraction. But look at the question. How much milk did she use? Well, if they are wanting to know how much milk she used, how come I'm going to say that I'm subtracting this? Because this would be what she used then. This is kind of wordy. So my thing is, when you see the question, here is 3/8 of a gallon of milk. Here it says 1/5 of that. So it's 1/5 of the 3/8. And what do I replace the of with? So that's how you would solve it. Multiply. Numerator times numerator, denominator times denominator. And you get your answer. What I want you to pay attention here is that you are gonna see when I go to the next one. Okay, this one, she has 3/8 of a gallon of milk. She used 1/5 of it. 1/5 of it. Okay, so then it's multiplication. You write it like that. I'm gonna show you another one that is going to be subtraction for you to see the difference now. Oh, here. Max had 1/2 of a candy bar. He gave 1/8 of the candy bar. Do you see the difference here? Here I have of a candy, of the candy. You have the same wording for both. If it's the same wording, then it's subtraction. 1/2, he gave away 1/8. Then you have to find common denominator and subtract. So I'm going to talk about this again with you. Here, they have the same wording. If it's the same, you're taking away from what you had before. If it's the other case, now let's say I had said instead, he gave 1/8 of it. Of it. He gave 1/8 of it to his friend. And look at the question, how much did he have left? That's another tip for subtraction here. But if he had said he gave 1/8 of it, you would not say that word candy bar, right? 1/8 of it. Then you would multiply. I know this is kind of, I have quite a few of this type for you to notice the difference. So let's see if you can pick this next one. So one more time. If this wording is the same, you're subtracting. And also look at this part here. If the wording is not the same, and even in the question, if it says he gave 1/8 of it, if it says he gave 1/8 of it, guess what the question would say? What fraction of the candy did he give? That's what it would say. He gave 1/8 of it. What is that? It would be actually 1/16 of the candy bar. It would be not subtraction. It would be multiplication. Let me try another one to see if it we'll do quite a few. Let's see this one. And if you see if you can, and I will circle and you're going to think about it, okay? Jay had 3/5 of a liter of orange juice. 3/5 of a liter of orange juice. And he drank 1/4 of it. He drank 1/4 of it. Pay attention to the question. How much did he actually drink? Mm. So I want you to look at this. It says 1/4 of it. So I want you to think and decide what operation am I using for this? Does anyone want to volunteer as a tribute? What operation do you think we are using? Falaki. Do I have what? Did he drink what? If it were subtraction, chances are the question would say how much was left. Also, if it were subtraction, it would say he drank 1/4 of a liter. Here, he didn't drink 1/4 of a liter. He drank 1/4 of the whole thing he had. Remember, the words don't match. And if I say 1/4 of it, this it is the 3/5, and of is multiplication. So there are quite a few tips here. Sorry. First tip is this of a liter, and here 1/4 of it. You don't see the word liter here. When you see liter and liter, subtract in that case for the problem. Here it doesn't say liter in both. It just says of it. So you multiply by this number. Second tip is if it were subtraction, chances are, not always, and I don't like to use that either because it can trick people, chances are the question would say how much was left. But see, even though we see the word drink and you think automatically he drank, it's subtraction, but they don't want to know how much is left. And in fact, it says he drank 1/4 of it, but the question still wants to know how much he drank. How is that possible if they told me he drank 1/4 of it? So what I'm saying, he didn't drink 1/4 of a liter, because that would be the answer. 1/4 of a liter is what he drank. When I say 1/4 of it, it just says 1/4 of this whole thing, which is not 1/4 liter. You have to figure out what that is. You multiply this by this, and it would give you then it would be the answer in liter. Whatever he drank, so 1/4 of 3/5 would be 3/20 liter. This is what he drank, and this is something that I could now, if I have 3/5, I can subtract the 3/20 that he drank and see how much is left. But you don't have to do it. They just want to know how much he drank of the whole thing. I know this is tough. This is not easy. It took me forever when I was a kid to grasp this one. And remember, my teacher didn't even say this to me. She just said 3/5 of, you multiply. But when I saw Drake, I thought, well, that is subtraction. But look at this. Of a liter, if it were subtraction, you would say he drank 1/4 of a liter. So you just take that little amount from what he had. And the question would look different too. Let's try another one. I know there's quite a few. Hopefully we're going to have plenty. So let's look at this one. Alice had 9/10 of her math homework to complete. She had 9/10 of her math homework. She completed 1/2 of her math homework before dinner. I mean, I don't even need this part. She completed 1/2 of her math homework. Do you see the wordings? Her 9/10 of her math homework. She did 1/2 of her math homework. Those words match. Chances are I'm heading to subtraction. Let's look at the question. How much of her math homework does she have left to finish? Another tip that it's subtraction. I'm going to challenge you. What would I write here instead? Instead of saying half of her math homework, what would I write instead if I wanted you to multiply? I would not say half of her math homework. I would say half Annalise. No, I'm not talking about substituting this. I'm just talking about the wording. Okay, we are trying to figure out the wording because I said 9/10 of her math homework, and here is the same, her math homework. We are going with subtraction, and also because it asks what is left. What I'm saying is, what would be different here if they actually wanted me to multiply instead? They would not say 1/2 of her math homework. They would say 1/2 of, I know I can tell, yes, this is really hard. They would say 1/2 of it. They would say 1/2 of it. They would say 1/2 of it. Then you would multiply. That in the question here would be different. How it would say how much of her math homework did she actually complete? If she completed 1/2 of this. Before we wrap this up, I will have you write down this about the wording. You can use it on the test. Let me try another one and see if we figure out that there are quite a few of them here. Jake picked 1/2 a pound of strawberries. He gave 1/2 of a pound of strawberries to his grandmother. What fraction of a pound of strawberries did he have left? What operation do you think you're going to use? These two, the wordings here match completely the same. Jimmy, subtraction. Very good. The two things that I'm looking at, the wording is the same, and they say what is left. If it were meant to be a multiplication, it would not say left. It would say how much did he actually give to his grandmother. But the question would say he gave 1/5 of it, or he would even say he gave 1/5 of the strawberries. Even though I may have the word strawberries there, but I don't see the word pound. He says 1/5 of whatever he had, which so you don't see the word pound. So you can still see 1/5 of strawberries, and it would still be multiplication because it's not talking about, he didn't give her 1/2 of a pound, he gave 1/5 of it. So it's different. Okay, but here it does have the word pound. Okay, let's try more time. Now, so here would be subtraction, 1/2 plus minus 1/5. Is it subtraction? Yes. You have to find the common denominator. It would be 10. I'm not going to solve this for you, boys and girls. When it comes to procedures like this, then watch those videos, okay? I want you to focus on the words. Let's see this one. Lindsay had a board that was, now I'm mixing up things. It could be adding, subtract, multiplying, dividing, I don't know. So far has been that multiplying or subtracting. But Lindsay had a board that was 4/5 of a meter. She used 1/4 of it for a project in woodshop class. How much of the board did she use? She used, you're gonna say, it's funny, it says she used this. Why is it that they want to know me? They want me to answer how much she used. If it tells me she used this, but she did not, it doesn't say how much as far as in meters. It just said 1/4 of this whole thing here. So based on the wording, for this is what she has, 4/5 of a meter. She used 1/4 of it. What operation would you use? And I would write 1/4 of it. Who can tell me what that it is? 1/4 of what? What did she use? 1/4 of what? Alice. which is what? So I would write 1/4 of 4/5. And we know what to do when we have that of. So I already kind of told you. It's multiplication. When would I use subtraction? If it said she used 1/4 of a meter, the words would be the same. And chances are, not always, you would have the word left here. I'm glad I'm recording this because then you can listen to it again. Okay, let's try another one. Now I'm not going to say, I'm not saying anything. I want you to read. Wish you had paper in front of you because you could circle the things. I want you to do that for me. Okay, so think a little bit and you're going to decide what operation are you using. And remember, I'm mixing up things, so you may find other operations. You need to understand it. I'm going to read the problem, but I'm not going to say anything, okay? Josh grew a sunflower that was 2/3 of a meter tall. She grew a sunflower that was 3/5 of a meter tall. How much taller was the sunflower Josh grew? One thing I have to say, when the question says how much taller was his flower, I can tell his flower grew taller than the girl's. Okay, the problem is telling that to me. How much taller was his flower? And that's what actually they want to know. They both grew tall, but his grew a little bit taller than hers. And that's what I want to know, that little difference. I'm saying things here as I read. Yanizel, what operation do you think we are using? In what? How did you figure that out? It could be. Say it again. Sorry. Go ahead. Okay, so here I have his was 2/3 of a meter tall, and hers was 3/5 of a meter tall. Okay, so it's the same. Uh-huh. That that's another tip. How much taller was his flower? So how would I think about it like I did? Okay, so right away I know his plant. So if you're subtracting, boys and girls, now here's another thing. What happens is that when you put it down to subtract, you flip flop the numbers. You have to understand the taller one is the one that you're going to start with. And which one is the taller one? Jimmy. Josh is right. So 2/3. And then you would take away Shay's. Now, again, as a reminder, you cannot subtract these two fractions because they are not the same denominator. Once you figure out, and I'm going to be honest with you, if you find the common multiples, it's going to be 15. You have to change these two. And when you subtract, the answer is going to have that 15, and you just subtract the numerators. Okay, once you change them as well. Okay, questions? All right, let's try another one. Alan cut a board that was, well, I'm going to have you read. You read and you decide. And I'll give you some time, and I would love for more people to participate. Okay. Mm, I see two tips. Let's see someone else that would like to participate. It's always the same ones. Christina, what operation would you use? Why? Wait, but well, you did not finish reading. Oh, I think you realized something, didn't you? What did you realize? You have to read the whole thing. You said just one half and one eighth. One half what? One half of a foot. And Ellie cut hers, that was what? Of a? Oh, are these the same wordings? They're not, they are the same wordings, right? Also, what does it say here? How much? What operation is that then, Christina? Mm, it's subtracting. And again, they're telling me which one has the longer board. It's Ellen, which is what? So half, take away 1/8. We can do this one because look what I see here. How can what can I replace the half with? Kaylee, I'm going to erase this. I'm going to put 4/8. And I can easily subtract now. 4/8 take away 1/8 equals 3/8. So Ellen's board is 3/8 longer than Ellie's. Okay. All right, let's try another one. Jake had 2/3 of a gallon of fuel for his go-kart. He used 1/4 of the fuel. There's something missing here that I have here. How much fuel does he have left? What operation am I using here based on the wording? I see quite a few hands going up now. That's good. It's always the same ones. Those are probably the ones that are going to ace it. Alice. Why do you think it's not? Yes. So here, this would be a little bit, this is hard because this would be 2 steps. Even though you saw the word left, you know it's still not subtraction. That's why I put it there, boys and girls. Even though it has the word left there, it's not I mean, you still have to do it. But the thing is, he has 2/3 and he used 1/4 of the fuel. It doesn't say 1/4 gallon. It says 1/4 of the fuel. I don't even know how to say that word. 1/4 of the 2/3. Okay, so once you multiply, you're going to find out what? How much he used. 1 times 2, 2, 4 times 3, 12. I'm going to simplify this. It goes to 1/6. This is what he used. I don't think you're going to see anything this hard on the test, though. I can guarantee you that. Okay? He used 1/6. Is that what they're asking me? No. So what would you have to do? You'd have to get the 2/3 that you had to begin with and subtract what he used to get the answer. This would be a 2-step problem. Now, I don't think you're going to see that one. This you may see on the FSA though. And if you do and you get it right, it could be what gives you a score of 5 on that FSA. Because on the FSA, they label questions like a level 3, level 4, level 5. So if this question would probably be a level 5 on the FSA. So if you answer that, that means it's bringing you up to that 5 on the FSA. And what I like it is that Alice read carefully this 1/4 of the fuel. It doesn't say gallon. So right away I multiplied 1/4 of the 2/3. But then you have to be careful once you get your answer. Okay, what does 1/4 of 2/3 is your answer is 1/6? What does that mean? Is what he used. But that's not what was asking. Yes, Denzel? For multiply, no. What I multiply, all I did, if it's fraction of another fraction, we multiply numerator times numerator and denominator times denominator. And remember, I have those videos there for you. The only time you need common denominator is when you add or you subtract. Okay? Sounds good? So this was a tough question. But see, this could throw a lot of kids off by going with that word left. But here, I would go with each step first. He used 1/4 of the fuel. So right away, I know it's not, he didn't say anything. He didn't use a fourth gallon. He used 1/4 of the whole thing. So then you have to do the multiplication. But then you cannot leave that answer. And believe me, if that were to be on the test, which is not going to be, I don't think so. I just looked at it this morning kind of quickly to see, because it was the coach who sent it to us. So she asked me to kind of review, see if there was nothing wrong. So I didn't see anything like this. But once you answer this answered this part. He used or the 1/6 gallon. Then you can say he used 1/6 gallon out of the 2/3. Then you have to do the subtraction to see how much was left. So this is a tough one. But at least you figure out that you would multiply first. So you would get at least half of it right. You would just have to understand you had another thing. Let's see this one to see. I want you to read, and then I'll read it too. I'll give you 30 seconds and figure it out. Also, figure out if they're tricking you with that type of question we just saw, that you'd have to do 2 steps. Or if you would just do the subtraction, or if you only do the multiplication, or only division, or only addition. Okay? All right, let me read it first. It took Jan 1/3 of an hour to complete her homework. It took Alan 1/6. Well, it doesn't say, but of an hour here. It's the same thing, to complete his homework. It took Jan 1/3 of an hour and 1/6 of an hour for Alan. How much longer did it take Jan to do her homework? So when you give me the answer, if it's whatever operation it is, I also want you to tell me how would you write that sentence. So I know you're writing the correct numbers in the right order. Okay. And again, I hate to, not that I hate, I love seeing those hands going up. I would love to see other kids participate. Very quiet. Others are very quiet. If you're listening, yeah, then maybe you are getting it. If you're not doing anything, I can tell. Jimmy, very good. Of and how much longer? So here, it gives you that clue. It's a subtraction, and these two are the same. And how would you write this? Is it 1/3 minus 1/6 or 1/6 minus 1/3? No, just what order would you write the subtraction? Is it, it's greater, right? And also it tells you in the problem, it says how much longer did it take Jan? So we know she took longer than this. 1/3 is indeed greater than 1/6. Then find common denominator, change your numerators, then you are able to subtract. These you have videos in Google Classroom. Okay, let's try another one. Alex ate 1/4 of a pizza. Marcus ate 2/3 of the same pizza. How much of the pizza did they eat combined? So I want you to read that and think. What operation are you going? Alex ate 1/4 of a pizza. So there was a pizza. He ate 1/4 of that pizza, and Marcus ate 2/3 of the same pizza. How much of the pizza did they eat combined? Dave. It says combined, right? Now we have to be careful sometimes, but here we also have pizza and pizza. Both are the same. So you're just combining those two numbers, which is 1/4 plus 2/3. My question to you, Dave, can you add the way it is right now? You just know what do you have to do first? Very good, which I'm not going to do here. Can you tell me what would be the same denominator for both? Yes, you're absolutely right. Some of you would choose to multiply, but which would be 12. But I like to go with the common multiples, but I would get to that 12 as well. Okay, so 4, 8, 12, 3, 6, 9, 12. Okay, very good. Good job, Dave. Okay, let's see this one. So now we saw an addition there. On Monday, Sally rode 4/5 of a mile on her bike. On Tuesday, she rode 2/3 of a mile. She rode this on her bike, and on Tuesday, she rode 2/3 of a mile. How many miles did she ride on Monday and Tuesday combined? Who can tell me what the operation is? I see more hands popping up. Oh, quite a few. Let's see. Flucky, because you found what? Combined, and they're talking about the same thing. It's like, sometimes I tell you, you add, let's say you had, when it's multiplication and you do addition and you were supposed to multiply because it says you had 4 baskets with 3 apples each. What is the answer? Well, 4 times 3 equals 12. And some of you will add 4 and 3. And I say, how can you add 4 baskets and 3 apples? What do you get? Well, I get 7. Well, 7 what? Apples. We can't because it says 3 apples. Oh, baskets. Well, it can't be because I have 4 baskets. So you have to pay attention. So here it's the same. I'm talking about miles in one day and some miles another day. Remember when I talked to you about reading the problem and not paying attention to the numbers? So if I say Sally rode some miles on Monday, and then on Tuesday she rode some more miles. How many miles did she ride combined? Well, she rode some miles on Monday, some miles on Tuesday. How many miles is that together? So, as another strategy, try to read the problems without the numbers and think about what is happening. They start doing that in kindergarten. They say, okay, you have some cookies. If I give you some more cookies, what are you going to do? So the kids, they know what to do. And then they talk about the numbers. Then they know they're supposed to combine those numbers. Okay? So try to understand the problem. Let's see another one. Max completed 1/5 of his math project on Wednesday night. He completed 1/2 of the same math project on Thursday night. So on Wednesday, he did this. On Thursday, he did this. How much of the project did he complete on Wednesday and Thursday combined? Oh, Lord. All right, let's see. Who else is going to participate? Let's see. I wish more people would participate. Some of you are so quiet. I have no idea what's happening. Dave. Combined, and he says he did 1/5 of the math project one day and 1/2 of the same project the next day. So, or you can, like I said, if you read without the numbers, he completed some of his math project on Wednesday and some of his math project on Thursday. How much did he complete together? Well, it's the same thing. Add those 2 days. You have to find common denominator between 2 and 5. Okay? Gabriel. Gabriel? Oh, are you keeping up with us? I need you to jump in and help because kids are jumping in to answer questions. I need you to do the same thing. And quite a few of you, I have not seen your names pop up there. Uh, I want everybody to read, including you, Gabriel, everybody. I want you to read that on your own and decide. What is it? Oh, okay, so come on, let's read. Let me read it myself because I haven't. Oh, right. All right, I need to see more hands up. What operation am I going to do? Let me read. Jane's paper airplane flew 5/6 of a meter, and Sarah's paper airplane flew 3/4 of a meter. How far did the paper airplanes fly all together? So if the plane flew a little, her plane flew a little bit, her plane flew a little distance, her plane flew a little distance. How much did they flew out? Did they fly all together? Let's see, Jonathan. I do see more hands. What operation is that? Adding, very good. It's 5/6 plus 3/4. Now, Jonathan, can I add these two right away? What do I have to do first? Very good. Now, some of you may choose to go ahead and multiply and do 6 times 4, 24, which would be, but you may have to, what is it, reduce later. If you do the multiples for 4 and 6, you're going to get to 12. 12 is a lot smaller than 24, easier to work with. Okay, very good, Jonathan. Let's see. Alice Scout Troop picked 37 pounds of blueberries. 37 pounds of blueberries. They split them equally between 5 girls. How many pounds of blueberries will each friend get? I want you to read and I want to see who can tell me what operation we are going to use here. Let's see. Shanice, division. How did you figure that out? Is there another thing that gave you a clue too? Okay, I have quite a few things here. One, when it says it picked 37 pounds, that's your total. Here, each gives you a clue that it would be division. Also, the word split equally. That means dividing. But my first question now, who is going to answer that, is what are they splitting? Because some of you are flip flopping those. What are they splitting? You have to ask that once you decide it's division, what are they dividing? What are they splitting? Yanisel. So that's how you would write 37 is divided by 5, or 30 over 5 is the same thing as this, remember? So these two could be a possible answer there for you to pick from. However, you can go ahead. This is greater than 1. So you're going to do the division, which we already know how to do the division. So who can tell me how to divide this? So I'm doing a few of them. What would I multiply 5 by to get close to 37? Dave, what is 5 times 7? Very good. So I put 35 here. 37 take away 35 equals 2. Now I'm done. So I write this as 7. So this is the same as 7 pounds, 7 and 2/5 pounds. Pay attention to my fifth. It's the same. Okay. And I could even go back from this to this. How? By getting this 7 and writing it 5/5, 5/5, 5/5, 7 times, and combine with the 2, you would give me those 37/5. Okay, so you can go back and forth. So far so good, boys and girls. I'm going to go to another one. There are 9 students sharing 5 boxes of candy. What fraction of a box will each student get? So I want you to think, what operation, what are the tips that gave you the clue that is that operation? And once you figure out the operation, I want you to tell me how you're going to write that sentence. The sentence, I mean, in numbers, okay? Oh, let's see. I see more kids popping up. More people. Let's see. Up, dropped. Let's see. More. More kids. Raise your hand. Come on, boys and girls, you can do it. Ah, it's the same ones. Christina. Okay. How did you figure out it was division? Okay. Now you realize it's division, right? Now we have to be careful. You have to ask yourself what? Oh, thank you. Yes, what are you sharing? What are they splitting? The boxes, the 5 boxes. So it's 5 divided by 9. And how can the question says though, write it as a, look at the question. It says what fraction? You know your answer is going to be a fraction. How do I write this as a fraction? Alice. Excellent. 5 divided by 9 is 5 over 9. So if I say 5 first divided by 9 second, I start with 5 over 9. And there you go. That's your answer. This is a very simple one, and you may have that on the test on Monday. All you have to do is figure out what they are splitting so you can write it correctly as a division and then rewrite it as a fraction. That's it. But I'm happy that nobody is splitting the kids to the boxes, right? Now, you can't cut the kids. Because guess what? For some of you who did this before, which is wrong, then you did what? You did let me see. You did the thing like this. One and you did this. 1 and 4/5. Well, if they want to know uh well that means you're splitting the kids that way, not the candy. Okay? So be careful. Good job, Christina. Let's see this one. Max biked 15 miles in 4 days. 15 miles in 4 days. If he biked the same distance each day, how many miles did he bike per day or each day? So I want you to think, what is the problem giving you? Is that a total? Is that a part of it? Do they want me to split it? Do they want me to multiply? Are they making groups? Are they taken away? What is it that's happened? If you could draw, what would you draw to represent what happened here? Okay, so I'm going to give you a little bit of time to think. Some of you already know what operation you're doing, but I want you to think. And this is one that many times get confused, but we'll see how it goes this time. Can you all read without the numbers? I'm going to actually read it to you without the numbers. Okay, so Max biked some miles in some days. Each day, he biked the same distance. How much was that each day? Let's see. Dave, what do you think? Per day, that means each day. So what are you going to add? Well, this is 15 miles plus 4 days. That's what you're adding. What is 15 miles plus 4 days? 19 what? Mm, no, here I cannot even add this. I can't add miles to days. That is not 19 miles per day. Also, Dave, how much did 4 days is that all 4 days combined? He biked 15 miles. It says 15 miles in 4 days. Did he bike 15 miles each day or in all 4 days? Does it say here he biked 15 miles each day? No, it says in 4 days. So 4 days, if I could even draw something like this, these are 4 days. This is the total he biked in 4 days. Also, Dave, I know he did not bike 15 miles each day. You know why? Because look at the question. How many miles did he bike per day or each day? So I can't say he biked 15 miles per day because I don't actually know that. That's what I want to know. All I know is that each day of those 4 days, each day of the 4 days, he biked the same distance. I just don't know how much that was. I know the total he biked. He biked 15 in those 4 days. One tip for you, boys and girls, if you choose to multiply 15 times 4, you are already telling me that he biked 15 miles each day. That's what you're telling me. 15 miles today, 15 miles tomorrow, 15 miles, 15 miles. Well, but how come they want to know that question? If that's what they want to know each day, I can't say 15 each day. 15 miles, you need to be careful. 15 miles is the total he rode in those 4 days. Every day he rode the same distance. How much was that each day? That combined gave him 15 miles. What operation would that be there, Dylan? It would be division. So because they gave you the total, so Dave, be careful, babe. The 15 miles in 4 days, that's the total. If you gave you the total, you can't add or multiply anything. You could be dividing or subtracting, but when they give me the clue that is the same distance each day, when it's that same each day repeated and they give you the total is division. So it's 15 divided by 4 or 15 divided by 4, which is 4 times 3 is 12. So it's 3 and 3/4 miles that he did each day. And if you actually add this now 4 times, you go back to 15 total. So when you read, also ask, what does this 15 miles in 4 days represent? It represents the total. If it is the total, you must not multiply or add. You can't because you already have the total. If you multiply or add, like you had done, Dave, and you got 19, you already get a number that is bigger than the total. So that doesn't make sense. That's your total. Okay. All right. Let's try another one. Time. Slow down. Mrs. Marks bought 8 cupcakes to share with her friends. She cut each one in half. How many cupcake pieces, pieces, pieces does she have or did she have? I want you to think what operation, what is she doing? If you were to draw, how can you draw that? You don't need to tell me how you would draw that, but maybe you can draw it. What does she have? What is she doing with that? And we want to know this. This will help you write the sentence correctly. Okay? And like I said, there are some of you I have not heard a peep from. I'm telling you, this one from the county, that is on Monday, this one here, I cannot give you retakes, just so you know. It is what it is. And good thing I'm recording this. It's going to be a humongous video, and I'll post it there. You can watch a little bit. Maybe you can skip forward if you need to. All right? There's only one person with their hand up. Is that only one person who knows what to do with this? So actually, when you answer my question, I'm going to ask whoever answers, I'm going to ask you a few questions, okay? And you go in that order, okay? To help, I'm going to help you with your thinking, in what order you should think, okay? So when I ask you the questions, is that order that I would go, okay? Let's see, Yanizel. First, Yanizel, my question is, what is it that Mrs. Marks have? So could you easily draw 8 circles for the cupcakes? Okay. Then what does she do with those cupcakes? Okay, so I'm going to actually draw one. I'm not going to draw all of them. Like I said, if it's a bigger number, 8 I could easily draw, but I'm not. I'm going to draw one and see what is happening here. So she's going to cut that cupcake in half. Okay, so then what is she going to do with all those? So she's going to cut all of them in half because she's going to do what with them? She's going to share with her friends, right? So the question is, you did this part, you drew the 8 cupcakes, you cut them in half. The question is how many pieces? So how many pieces is that, Yanizel? 16. Now, let's say, but Miss Miller, what if it's a humongous number and I don't want to draw? Or like I said, you could draw one. So this is one cupcake. It gives you 2 pieces, right? Another cupcake, another 2 pieces. So I have to do count by, you're going to be counting by 2, 8 times. Oh, then I kind of said multiplication. But we see the word sharing here. So what am I sharing? The cupcakes. Or what am I doing to those cupcakes? I'm cutting them in half. 8 divided in half. When you see this on the test, think about it. This 8 is the whole cupcake that you cut in half. Oh, I get 2 pieces here. So 8 divided by half, you're going to get more pieces, right? You're cutting it in half because maybe you don't have enough, so you have to get more pieces. Then you get the 16 pieces. Now, some may say, oh, I remember that starting with a whole ends with a whole. That works only for the division, not for the multiplication we have been doing. But if you draw, you don't have to worry about it. And also look at the question, how many pieces? They want to know the number of pieces she gets. Yes, Falaki? Yes, and you can look at the tips I gave you. I have the notes for you how to multiply. I asked you to write those down. And that is another good tip that Falaki figured out because it was 4 times 3/5, right? The only time when you divide, if you paid attention, you are dividing by a whole by a fraction or a fraction by a whole. But what happens is that the numerator is always 1 because in 5th grade, you are only dividing by unit fractions. So you have to have that one. So that 3 was a tip to her that, oh, that cannot be it because it's only when we are doing by that one, the unit fraction. Okay. All right. Good thinking there, Flucky. The astronomy club had a pizza party with 8 pizzas. Each pizza was cut into 6 or into pieces that were 6, right, of the pizza. How many pieces of pizza did they have in all? Now, I want you to draw this. Go ahead. This is something that if you have this on the test, you should not get wrong. This is something you could easily do with your family. You're going to have a pizza party. You're going to invite your friends. You're going to buy 8 pizzas and you're going to cut them into 6. Whenever we have pizza parties here at school, we have to kind of figure out how many slices we need. So figure out what are you going to do with those 8 pizzas first to figure out how many pieces I need. And this is a clue also. Now it's telling you what to do. All right, whenever you're ready to participate. I'm waiting to see if there are more volunteers. Gabriel, what are you going to do, babe? Huh? Well, did you draw the 8 pizzas? What did you do with each pizza after you drew them? What are you supposed to do? That's fine. I'm guiding you through it. Can you draw 8 pizzas? If you already did draw, that's fine. Do you have 8 pizzas there? What are you going to do with each pizza? You're gonna cut them into what? Okay, so cut each pizza into 6 for me. Or, like I said, if you don't want to draw the 6 like this for each pizza, you can do this. You're cutting into 6 slices, right? So after you did that, Gabriel, after you drew your 8 pizzas and you cut them into 6 like this, the question is how many pieces do I have in all now for all 8 pizzas combined? Are you finished drawing your pictures? Okay, don't worry about the pencil. If you drew your pictures, if you drew your 8 pizzas and you cut each into 6, like I have here, each one, how many pieces do you have now? I'm actually drawing here for you to see. These are my 8, sorry, my 8 pizzas cut into 6. How many pieces do I have now? Yes, It says here in all. Come on, babe. How many slices do you have in all? How many? You may have miscounted a little bit. You were close. It's 48. Because like I said, instead of drawing, because this can get hard to count, right? You can tell that when you cut into six, you got six slices there, right? Instead of, usually we cut into eighth, right? Usually we cut pizza into eighth, but they cut it into six, so the slices are a little bit bigger. So six and six and six and six all the way is 6 times 8, which is 48. Okay. All right. That's good job though drawing those pictures. You just have to be careful counting those slices. Okay. Let's see this one. Jane has a ribbon that is 1/4 of a meter long in all. That is the whole size of her ribbon is 1/4 of a meter. It is split into 5 pieces. How long is each piece? So what does she have and what is she doing with that? That's what is a very simple, and I read it, I see right away what I'm doing. Okay. So she has 1/4 of a meter long and she's splitting that into 5 pieces. Dave. And what is it that she has that she's dividing? Okay, so she's dividing that fourth by how many pieces? Now we go back to that tip, right? It's a fraction with the one that you can, if it starts with a fraction, the answer ends with a fraction. What would the answer be, Dave? 1/20th. Very good. Now, boys and girls, if you get confused with that, I can represent this with a picture. So 1/4, right? So I have to have a fourth. So even though this is the whole meter, this is a whole meter, but she doesn't have a whole meter. She has only 1/4 of it. So this is the only part she has is this here. Okay, this is the only thing she has. And this is what she's dividing into 5 pieces. So she cuts this into 5, but look at this. I already go all the way. And then how long is each piece? So it's one piece here is 1 out of 20. So I could draw to show that picture. What you have to remember, you have to figure out that 1/4 in your picture. Okay, some may do the picture like this instead. This is the whole meter. This is 1 meter, a whole meter. But she has only 1/4 of it. And this is what she's going to split into 5. Then you do the same thing with the others. I have quite a few videos from Khan Academy showing this on Edpuzzle. Okay, very good, Dave. So it's 1/20th. Kristen, you have a question? You can go. I'm moving on, okay, because time is ticking. It took half an hour for Alice to complete 5 math problems. So she tried to understand this. Okay, in half an hour, Alice completed 5 math problems. Now, you all know, right? Some questions we answer faster than others. In this case, she spent the same amount of time on each problem. So whatever she spent on one problem, she spent on the other one. It was all the same for the 5 questions. And that's what we want to know, how long it took her to complete each problem. Half an hour represents what as far as, is that a total that she spent on the 5 math questions, or is it what she spent on each question? Think for carefully, okay? Because this is when you can get too tricked. This half an hour was the total for the 5 questions or for each question? Alice, since it's you there in the problem, half an hour, was it the total for the 5 questions or is it for each question? Very good. This is the total for all 5 questions. How can we draw this easily like this? So there were 5 problems, and the total she spent is the half an hour. Look at this. And it says she spent the same amount of time on each problem. So whatever she spent here, I'm going to put as an X. She spent an X here, an X here, an X here, an X here. You know, in middle school, you're going to see letters for numbers, right? So this, if I put X, 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 that means they are all the same. If I put X, Y, X, Y, X, Y, then the numbers are different. They're all the same. And the question actually wants to know each one. This is what they want to know. Each one. They gave you the total. If they gave you the total, you must not multiply or add. Nope, 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 nope. You're going to divide or subtract, but these are all the same. So that's a clue for one of the 2 operations. Jimmy, what would you do? Uh, yes, you see, when we think about math, half you can do 30. Oh my goodness. He knows, this is amazing. He knows half an hour is 30 minutes. So he can do 30 divided by 5. What is 30 divided by 5? Alana? 6 minutes per question. Well, let's go with let's go, if you do it this way though, let's see if it works. If you were to do, the thing is, Jimmy, you figure out 6 minutes per question, right? But you may not see that in the answer sometimes because they want you to do what? They want you to do the half divided by 5, which would be 1/10. That is 1/10 of the hour, which is 6 minutes. 6 minutes is 1/10. Uh, See how math goes up back and forth. 60 minutes is an hour. She spent 1/10 of those 60 minutes. And 1/10, remember, is 10 times less. 10 times less than 60 is 6. But on the test, you would probably see the 1/2 divided by 5. The answer would be 1/10. It would be 1/10 of the hour for each question. Now, I don't think they would put the 6 minutes there, but that is going above and beyond there. Good job. As long as boys and girls, you know you are dividing the half by the 5. Okay, let's see this one. Mary is making dolls. Mary is making dolls. It takes half of a yard to make 3 dolls. I want you to draw, first of all, draw a whole yard. Draw a whole yard for me. Okay, I'm going to draw a whole yard here. I want you to draw that whole yard. Then the next question for you does is how much of that whole yard is she using to make those dolls? Christina, a half. So I'm going to cut that whole yard in half, and this is the half, right? Is this the half? Okay, you can also do here. This is another what? Half. Now, how many dolls does she make with this half? Look at this. Now, you're fine. But let's see someone else maybe. What is she doing with this half here to show that she can make 3 dolls with this half? What are you gonna do with this half? Let's see if I can see more hands up in the air, up in the air. Though I don't see the hands up in the air, I just see the little hand on the computer. Yanizel, with this, she's using half to make what? So how can you represent the 3 dolls here with this half yard? What would you do here? Yes, because each one here is what? What does it? No, each you cut into three. Each one is what? For one what? No, one half is what you had. You had, I know it's 1/3, but this Chinese in Ichigo, this 1/3 that you cut is for each doll. So here is gonna be for one doll, here is for another doll, here is for another doll. That's just so half yard. She makes 3 dolls. How many yards of fabric does it take to make only one doll? So I want only this little doll here. But remember, whatever I do to this half, I need to do to the other half. What is that now? This is for one doll is one what? Jimmy. 1/6 for each doll. See, one half of the yard, she makes 3. So of the whole yard, how many yards is just 1/6 is a smaller piece to make for one doll. Well, also here, 1/2 is the total she uses for 3 dolls. 1/2 is the total she uses for 3 dolls. 3 dolls uses half. I want to know only one doll. So you have to cut this by the 3 dolls to see how many. So it's 1/2 divided by 3, starts with a fraction, ends with a fraction, is 1/6. But again, draw this. It says 1/2 of a yard. Well, draw the yard, but she's not using the whole yard. She's using only half of it. This is her half yard. What does she do with this half yard? She makes 3 dolls. Well, so she needs this little piece for a doll, this little piece for a doll, this little piece for a doll. Well, she's going to do the same thing here. Now, this is the whole yard. In one doll is 1/6 of the whole yard. Okay? No, got a little bit. You're going to be just fine, I feel like, with this. Oh, did I finish? I finished my slides. Let me stop